Picture this. It's 4 p.m. on a Friday. You're 3 hours deep into a feature refactor, your mental model perfectly loaded. Then, Slack lights up. Production is down. In the old world, you'd stash, switch, scramble, and lose everything you were holding in your head. But there's another way, and it's been hiding inside Git the whole time. Before we can understand work trees, we need to look under the hood of Git itself. When you run git init, Git creates a single hidden directory, .git, and that directory becomes the brain of your entire project. Every commit, every branch, every version of every file you've ever saved lives inside it. Your regular project files, they're just a window into that brain.
Here's something that surprises almost every developer the first time they really see it. A branch is not a folder. It's not a copy of your code. A branch is just a sticky note, a pointer to a single commit. When you make a new commit, that sticky note moves forward. Head is just another pointer, tracking whichever branch you're currently on. Lightweight, elegant, but with one hidden consequence.
When you switch branches, Git rewrites your working directory to match the new branch. Instantly, files appear, disappear, change. And while Git handles the file system flawlessly, your brain doesn't. Cognitive science calls it context switching cost. Developers know it as that sinking feeling when you come back to your feature and can't remember where you were. This is the problem Git worktrees were born to solve. A Git worktree lets you check out multiple branches simultaneously, each in its own directory on your file system, all connected to the exact same Git repository. Think of it as parallel universes sharing the same history book. Each universe has different files on the surface, but they all read from and write to the same underlying Git object store. One repo, multiple worlds, no cloning required. Watch what happens at the file system level when you add a worktree. A new directory appears. It looks like a fresh repo from the outside. But crack it open and you'll find not a .git directory, but a single .git file. That file is a pointer. It beams straight back to the original repository's object store. No duplication, no second copy of your history, just a lightweight new window into the same room. The .git file in a linked worktree contains exactly one line, the path back to the parent repository's worktree record. It's the most minimal contract imaginable. And inside the parent's .git/worktrees folder, Git keeps a matching record, the branch that worktree is on, its head state, and a lock file to prevent two worktrees from ever checking out the same branch simultaneously. Git enforces exactly one rule about worktrees. No two worktrees can check out the same branch at the same time. Git literally locks the branch with a lock file to prevent it. And this makes perfect sense. If two directories both claimed to be on the same branch and you committed from each, Git would have no idea how to reconcile the diverging heads. The Git lock is protection, not limitation. Let's build this from scratch. One command, git worktree add, and Git does 5 things in under a second. It creates the new directory, checks out the branch into it, writes the .git pointer file, registers the worktree in the parent's records, and locks the branch. 5 steps, 1 second, 0 disruption to your current work. Your feature branch stays exactly where you left it. The moment worktrees click, you start seeing them everywhere. A production hotfix just dropped? Open a new worktree, fix it, push it. Your feature branch never knew anything happened. A colleague asks you to review their PR? Check it out in a fresh worktree without touching your current work. Running a test suite that takes 20 minutes? Let it run in its own worktree while you keep building. Here's where worktrees genuinely beat the naive alternative, just cloning the repo 3 times. Every clone duplicates your full Git history. A repository with 10 gigabytes of history becomes 30 if you clone it 3 times. Worktrees share every single Git object. Only the working files differ. 3 worktrees on a large monorepo might cost you a few megabytes of extra disk space compared to gigabytes for clones. At any point, one command gives you a complete map of all your active work trees, their paths, their current commit, and the branch each one holds. This is your control panel. And notice that first entry, your original project directory is itself a work tree, the main work tree. You've always been in a work tree. Git just didn't give you more of them until you asked. When the work is done, cleanup is just as elegant. Git worktree remove tears down the directory, releases the branch lock, and scrubs the registration record from .git/worktrees, all in one step. The branch itself lives on and gets history, safe and untouched. And if a worktree's directory gets deleted by accident without the proper command, Git worktree prune will find the dangling record and clean it up for you. This is what a day looks like with worktrees in your workflow. Your feature branch becomes a place, a physical directory you can walk away from and return to exactly as you left it. No stash pop. No reorienting. The morning's work is still open, still in context, waiting exactly where you left it. Parallel work stops being a disruption and starts being a superpower.
The hotfix scenario is where most developers first encounter the pain that worktrees solve. The old way asks you to perform a ritual: stash, switch, fix, switch back, pop, reorient, every single time. And stash pop failures, merge conflicts on pop, and the simple cognitive cost of rereading your own code make it genuinely expensive. Worktrees cut the ceremony entirely. The fix happens in a parallel world. Your world never notices. Here's a use case that pays off immediately in large projects, long-running builds, and test suites. Instead of watching a progress bar while your primary work sits frozen, you spin up a work tree for the test run, kick off the suite, and walk right back to your feature. 20 minutes of tests become 20 minutes of additional feature work. Multiply that across a week, and you've reclaimed hours. Open source maintainers and code reviewers discovered worktrees almost immediately. Checking out a contributor's PR branch into a dedicated worktree means you can run their code, poke around, even make local test modifications without any of that touching your main development flow. When the review is done, Git worktree remove, and it's gone, cleanly. No branch switching, no leftover checkout state. Teams maintaining long-lived parallel branches, documentation, release candidates, stable maintenance branches, find worktrees transformative. Keep a Get Pages worktree permanently open next to your main working directory. Fix a typo in docs while reviewing the corresponding code change in the same editor session in adjacent folders. The friction between code and everything else drops to nearly zero. So how does this stack up against the two things developers already reach for? Stash is fast but lossy. It serializes your work into a commit-like object and asks you to trust the pop. Cloning is safe but expensive. Full history duplication, no shared objects. Worktrees thread the needle. The safety of a separate checkup, the efficiency of a shared repository without the ceremony of either alternative. Git has always been a distributed, powerful system, but most developers only ever open one window into it at a time. Worktrees don't change what Git is. They just remove the artificial constraint that said you could only look at one branch at once. Your entire history, all your branches, all your context, it was always all there, all at once. Worktrees just finally let you see it that way.